Hello friends, welcome back. In this session, we are going to go with the 7th set of questions from the Electrical and Electronics Engineering Interview Readiness series. I'm sure you like it, and if you have any questions, you can type it in the chat box. I'll be happy to answer. Let's get into the first question. Why Ohm's law cannot be applied to semiconductors? Is it so? Yes, Ohm's law cannot be applied to semiconductors. Semiconductor devices are non-linear, unilateral devices. Examples could be diodes, transistors, etc. They permit the flow of current only in one direction, which means the ratio of the voltage to the current does not hold good for any voltage variations. So, obviously, Ohm's law cannot be applied. Semiconductor devices, as the diodes, transistors, they permit the flow of current in one direction. That's the main reason. Right. What is a unilateral device? A device that conducts in one direction is called as unilateral device. They generally oppose the current flow in the other direction by means of creating a very high resistance. A simple example could be a p-n junction diode which conducts only when it is forward biased and does not conduct when it is reverse biased. This is a very simple point, right? The forward bias, the p-n junction diode conducts, the reverse bias, it doesn't conduct. Well, what is electric power? Electric power is the rate at which the work is done. Power means the rate at which work is done, or the energy is transformed into electrical circuit, or it can also be called as a measure of how much energy is used in a given time span. To make it very simple, power is the product of voltage and current. Its unit is watts or joule per second. So please remember, this is a very important question. We connect a LED bulb and air conditioner to the same power line. Do they consume the same voltage, current or power? Well, to answer this, I need to take an example, and that's what I'm going to do right now. Let's consider a very simple example where an air conditioner and an LED bulb are taken into picture. An air conditioner consumes a power of 2300 watts, but the LED consumes a very little power of 23 watts. Now let's go ahead with the calculation. Power consumed for air conditioner is 2300 watts in our case, but in this scenario for LED it is 23 watts. What is the formula we have heard of already? P equal to B into I. Now 2300 equal to 230 into I. The assumed or the rated voltage is 230 volts only, and so I is 10 amperes. Similarly, 23 is the power consumed. 23 equal to 230 into I. So I would be 23 by 230, which is 0.1 amps. That's all. We have already given the answer. And here we have taken the rated voltage as 230 volts, which plays a major role. You need to check about it if you are given with the different data. What is Kirchhoff's voltage law? In a closed loop, the sum of potential rise is equal to the sum of potential drop. That is, the voltage rise is equivalent to voltage drop sum. The sum of voltage rise is equivalent to sum of the voltage drop. It means sum of the potential differences around any closed loop in a circuit need to be zero. That's the major point. So the law says that the sum of the potential differences around any closed loop in a circuit should be zero. That's all. We have completed the 5 questions. I hope it was useful. In case you have any questions, please go ahead and type it in the comment section. If you like the channel and content, kindly subscribe. Thank you.